In this video, I'll be taking you through how to look up the allowable stress for any material out of B31.3 Table A-1. We have our formulae inputs here in the blue cells, and in the output cells below, we're using the add-in to look up the allowable stress, the outer diameter, make a thickness calculation, select a schedule to meet that thickness, and then to list the exact thickness of that schedule. Now I want you to notice the yellow cell, the number of matches, being 3 for this material. So what it's telling us is that the description A106 by itself is not specific enough to individualize to select only one material. So what should we do here? Well, how about we go with our old favorite A106 grade B, or GR.B for short, and that brings it down to one match. You can also use the whole word grade, and none of this is case sensitive, by the way. Over to the right we have excerpts from the table and column names shown in red, which we can use in naming our materials. Now the first part of the material name, in this case A106, is always assumed to be the spec, so we don't actually use the word spec in the name. But the rest of the red columns, and particularly J to Q, would normally be used when we're naming our materials. And we can use these in any combination or order, with perhaps the exception being the size column, which is generally a separate input to the formula. So let's go through some more materials to demonstrate. So by itself, A789 has quite a few matches, but if we add something more descriptive, such as grade 2205 for instance, that brings it down to only one match, and we know we then have our desired material. So if we pick a different material such as an S32101, we should expect a few more matches. So if we have A789 and then we type UNS S32101. Now that's actually only showing one match, but if you'll notice the size input cell here, what the add-in is actually doing is it's looking up that size column and finding only one match for that size of material. The meaning of the size column being thickness, or occasionally diameter, by the way. So when I delete that formula input, we now find 2 matches. In fact, most of the time you probably will be leaving that size input blank, because for most materials there is no particular restriction on size. But for S32101 there are a couple of size ranges. When you leave the size input blank, it will just pick the lowest size range when it looks up allowable stress. Now if you're doing a thickness calculation, you won't know your thickness in advance. So what you can do is assume a thickness, do a calculation, then select a thickness, and then look up the allowable stress again as a cross-check. Don't forget you can also use the function arguments box to get all the inputs to the formulae and to get some help text for each of the inputs. And the size can be any number, just so long as it's within the correct size range. So if we enter, say, 0.1, we're in the lowest size range, we have one match, and we have the higher allowable stress, which is as expected. Now let's look at another material. How about A312 grade TP321? As we have a size input, we shouldn't expect too many matches, but we are getting a couple of matches for this one. This is actually only one of the few materials in the table where a size is specified, but it's still not quite sufficient to narrow it down to only one result. You can see looking here, there's not actually much to differentiate these materials. The only thing that really stands out is in the notes column. So what we can do is we can type notes followed by the entry that we're interested in, say note 30. And that's brought it down to only one match. If we wanted the other option, notes 28 and 30, we can type it exactly, or we can use the wildcard symbol, the % sign. That could also be entered as %28%, for instance. And again, we're only showing one match for that one. Let's have a look at another material just to see how the size ranges work in action. So in the red box here we have B371 UNS C69300, And at 0.1 inches, we're in the lowest size range and the highest allowable stress. Moving into the next size range, 0.6 inches, that brings us down to 23.3 KSI. And the third size range, 1 to 2 inches, pick anything within there, and that brings us down to the lowest allowable. So let's pick another material from the nickel alloy range, B164 UNS N04400 Monel. And that one's also giving us 2 matches, even with the size specified. Looking at the table, the only difference that we see between these two materials is what's specified under the column known as class condition temper. And we do like to abbreviate things here in Oz, but no one really wants to type that all out, so we just call it CCT. So we type CCT followed by H.W. and that brings it down to 1 match. And if we want to go with the other material, its description being an.forge or annealed and forged, we can type that in. However, that does bring up a point. We need to replace spaces with underscore if your description has a space in it, and there are very, very few of those in the table. As an alternative for this one, instead of using the CCT column, we could have actually used the UTS or the SMYS columns. So instead of the CCT, you could type UTS 70 or 80. You wouldn't probably normally do it this way, but that's just another option if you like. And with that, I've shown you how to look up the allowable stress for any material from the whole table. Thanks for watching.